Hi guys, how are you? Here is a very interesting question. If two substrate is treated with NaHMDS, what will be the product? As you may see that the structure of these two substrate is very big enough. Actually, the reaction of these two in presence of a base is called Julia olefination. Here the characteristics functional groups are this SO2 and this tetrazole in a substrate, and here is a carbonyl compound, this SO2 and this tetrazole. These three are indication for this Julia olefination. Julia olefination. So first we will see the general reaction and the mechanism for Julia olefination, and then we will come to this specific reaction. So in Julia olefination, this is treated with a base, let's say ETMGBr, then an aldehyde, then Ac2O, acetic anhydride. What will happen? SO2 pH, let's say this is R1, this is R2, R2OAC, and if it is reduced with sodium amalgam, then an alkene will result, with E configuration. As these two are in transposition, so this is E configuration. So this is the Julia olefination. So what is happening here? This is a sulfoxide. When treated with a base, here two protons are there. So one of this proton will abstracted by this base. So Et minus will take one proton and the corresponding anion will formed. Then it will react with this aldehyde, and a carbon-carbon bond will form, SO2 pH. Here this will be O minus, R2. Now with Ac2O, CH3 C double bond O, so it will attack here and it will be converted to OAC group, SO2 pH, R2OAC. Now if it is treated with NaHg, then it will be converted to the alkene. So how it is happening? Here the one of this photon here will be taken by the base, so the corresponding anion will be formed, which will be stabilized by this SO2 pH group. Now this will be O minus. Now this OAC group will be removed, so it will be it will formed, and after that sodium will give one electron and it will be removed. So the corresponding vinyl radical will formed. Again sodium will give one electron, so it will turn into vinyl anion. So it will turn into vinyl anion, then it will take one proton, then will be converted to the olefin. Here predominantly E-alkene will be formed. Here the vinyl radical which will adopt this geometry as we see in Barch reduction. Here the R1 and R2 will be in trans to reduce the repulsion between these two. So the E-alkene will be formed predominantly. Now here one modification was happened. It is called one-step Julia olefination. One-step Julia olefination. In this reaction, the substrate taken was like this. Tetrazole derivative. This is a tetrazole derivative, and then it was treated with a base called KHMDS or NaHMDS. Sorry, this will be R1. Here there will be alpha carbon, so it will abstract a proton from here and the corresponding anion will be formed, which will be stabilized by this SO2 group. Then it will be react with an aldehyde group to form the corresponding alkene with predominantly E configuration, that means trans configuration. So how it is happening? As you can see that here the proton will abstract and the corresponding anion will be formed, then it will attack into this carbonyl carbon. So what will happen? Here R1, sorry, it will be here will be pH, that tetrazole derivative, and it will be R2O minus. Then it will attack into at this carbon, then a 5-member cyclic intermediate will be formed. Here it is oxygen. So it will be anion. Here the pH, and here will be the pH, and here will be a double bond. Now as it will come back, this bond will break. So what will happen? Now it will be O, this is R2, R1, here S double bond O, O minus. Now this will break and the corresponding product will be formed. It will be O minus, pH this. So this product will form. Here the alkene will predominantly have the trans geometry. So now we'll come into our reaction, which was like this. Here the SO2 group was there, and tetrazole group was there. Here a formyl group. Now it is treated with NHMDS. So preferentially one of this proton will be abstracted, and then it will attack to this formyl group, and a bond between this carbon and this carbon will form, and the Z alkene will form. These two group will eliminate. So our product will be like this. Again I am writing this. So in our reaction, our substrate was this plus TeSO double bond O. So this carbon and this carbon will form a bond, NaHMDS. NaHMDS is sodium bis trimethyl silyl amide. The structure of this is Na plus N minus, here SiMe3 whole 2. So this is the base. It will abstract this proton, and then the one step Julia olefination reaction, which I already shown before, this will happen. So a coupling reaction will take place, and the product will be this. So here a double bond will formed, and then from this carbon again there will be a double bond. Here a ethyl group is there, and then this ethyl and this will be trans, so this will be in this position, OTS. So this will be our product. Here this double bond has E configuration, and this double bond has also Z configuration. Here the priority of this group is higher, so this has Z configuration. and these two group will be in trans position. So this will be our product. So guys, if you have any doubt regarding this video, please let me know in comment box, and to get more such interesting videos, subscribe my channel. Thank you. Have a good day.